In this lecture, we will study the sequence networks of transformers and loads. We have already studied the sequence networks of generators and transmission lines. Now let us study the sequence networks of transformers and loads. So first, the sequence networks of transformers. So we know that a transformer is a symmetrical static piece of apparatus, and hence the phase sequence of supply voltage is not important here. So a transformer is a static piece of apparatus. So as it is stationary, the phase sequence is not important here. So phase sequence is important in the case of rotating machines only, because the phase sequence determines the direction of rotation. So in case of this static apparatus, that is for transformers, phase sequence is not important. And we know that positive sequence and negative sequence components differs from each other in terms of phase sequence only. So as phase sequence is not considered here, positive sequence impedance and negative sequence impedance are equal for a transformer. Z1 is equal to Z2. And even though zero sequence impedance is slightly different from positive sequence and negative sequence impedance, it is also considered as equal to positive and negative sequence impedances. So for a transformer, Z1 is equal to Z2 is equal to Z0. That is, all sequence impedances are equal for a transformer. Now, if the neutral point is grounded through Zn, if the transformer is star connected and the neutral point is grounded through Zn, then 3Zn will appear in the zero sequence network. So we have seen this already in the case of generators. The neutral grounding impedance Zn will be present only in the zero sequence network. So if neutral is grounded through Zn, 3Zn will appear in the zero sequence network in series with the zero sequence impedance per phase. Now, the positive and negative sequence impedances are represented as series impedances in their respective sequence networks. So the positive and negative sequence networks of transformer can be drawn easily. It is similar to that of transmission lines. The respective sequence impedances are represented as series impedances in their sequence networks. So for positive sequence networks, the positive sequence impedance Z1 is represented in series with the transmission line. IA1 is flowing through it and terminal voltage is VA1. Similarly, for negative sequence network, we have to represent Z2, current IA2 and the terminal voltage VA2. But the zero sequence network is different from this. So there are some factors to be considered before drawing the zero sequence network. The zero sequence network of a transformer depends on the type of winding connection, that is, whether the winding is star connected or delta connected. And also, if the winding is star connected, whether the star point is grounded or not. So these two factors are important while drawing the zero sequence network of a transformer. So we have to check the type of winding connection, whether it is star connected or delta connected, and if the winding is star connected, whether the star point or the neutral is grounded or not. So there are some assumptions to be considered while drawing the zero sequence network. They are: when magnetizing current is neglected, primary winding will carry zero sequence current only if there is a path for zero sequence current in the secondary winding, and vice versa. So, primary winding will carry zero sequence current only if there is a path for zero sequence current in the secondary. സെക്കൻഡറിയിൽ സീറോ സീക്വൻസ് കറൻറ്റിന് പാത്ത് ഉണ്ടെങ്കിൽ മാത്രമേ പ്രൈമറിയിൽ കൂടെ സീറോ സീക്വൻസ് കറൻറ്റ് ഫ്ലോ ചെയ്യുള്ളൂ. ആൻഡ് വൈസ് വേഴ്സ, ദാറ്റ് ഇസ് zero sequence current will flow through the secondary only if there is a path for zero sequence current in the primary. Okay, now when will a path be available for zero sequence current? See, If the neutral of a star connected winding is not grounded, then there is no path for zero sequence current. So there are two possible winding connection. So first of all, consider the star connection. So star connected winding can be of two types: star point grounded as well as star point ungrounded. So if the neutral of a star connected winding is not grounded, there is no path for the zero sequence current. So we have seen already, for a zero sequence network, IA0 plus IB0 plus IC0, that is 3 times IA0 will flow through the neutral wire to the ground. And if the neutral is not grounded, then there is no path for the zero sequence current. Now, if the neutral point is grounded, the zero sequence current will flow in the star connected winding and also through the lines connected to that winding. Okay. If the neutral is grounded, then zero sequence current can flow through the winding as well as through the lines connected to the winding. Now coming to the delta connected winding. Zero sequence current can circulate in a delta connected winding, but the current cannot flow through the lines connected to it. Okay, these are the points to be considered while drawing the zero sequence network. So first point is, current will flow through the primary. Zero sequence current will flow through the primary only if there is a path for zero sequence current in the secondary, and vice versa. Now, for star connected winding, the current will flow through the winding only if the star point is grounded. If the star point is ungrounded, then there is no path for zero sequence current. For grounded star connection, zero sequence current will flow through the winding as well as through the lines connected to the winding. For delta connected winding, current can circulate in the winding but cannot flow through the lines connected to it. Now let us try to draw the zero sequence networks for different winding configurations. Okay. So first of all, let us consider the ungrounded star connection. Ungrounded star, ungrounded star. So we know if any of the winding is ungrounded star, there is no path for the zero sequence current. So the network has to be represented as a series impedance. The impedance has to be represented as series, and as the star winding is ungrounded, there is no path for the zero sequence current. If there is no path for the current, then provide a break in the circuit in order to show that current will not flow through it. So this will be the zero sequence network. Now the next configuration is primary ungrounded star and secondary is grounded star. So here there is no path for current in the primary and there is a path for current in the secondary, but we know that current will flow through the secondary only if there is a path for current in the primary. So current will not flow through the winding. Okay. So here also there is no path for current, so there should be a break here. The same circuit. Now the opposite configuration, primary grounded star and secondary ungrounded star. Here also there is no path for current in the secondary, so current will not flow through the primary also. The same circuit. Zero sequence current will not flow, so there should be a break. So fourth configuration will be grounded star, both primary and secondary grounded. So here there is a path for current in the primary. Also there is a path for current in the secondary. So there current can flow both in primary and secondary. So current can flow through the zero sequence network. The network should be shown as a continuous circuit. So current can flow through this and also through the line connected to the winding. Z0 is the primary winding is shown as M. So current can flow through the line connected to M as well as to N. So we have to show a continuous network. So now the next configuration is ungrounded star delta. Ungrounded star delta. So as primary is ungrounded, there is no path for current. So current will not flow through secondary also. So the previous diagram, the diagram with a break here, in order to show current will not flow through this. So now the opposite configuration, primary delta, secondary ungrounded star. So there is no path for current in the secondary. So current will not flow through the primary also. So circuit with a break. So now grounded star delta. So primary is grounded, then there is a path for current, and secondary is delta. So there is a path for current in the primary and secondary is delta. For delta connected winding, current can circulate in the winding but cannot flow through the line connected to it. So see, the secondary is delta. So for a delta connected winding, current cannot flow through the line connected to it. Line connected to delta winding is N. So there should be a break. Current cannot flow through the line connected to the delta winding. So we have to provide a break here, but current can circulate through the winding. So this side has to be grounded. Secondary side has to be connected to the ground. So current can circulate like this. So current can circulate through this path. Okay. So for star connected winding with a grounded neutral, current can flow through the winding as well as through the line connected to it. M-il kuda flow cheyan pattum, but secondary is delta connected, and for delta connected winding, current can circulate like this but cannot flow through the line connected to it. So cannot flow through line N. So here there should be a break, and for current to circulate, this line has to be grounded. Okay. Now the opposite configuration, primary delta and secondary star point grounded. So here also there is path for current both in primary and secondary, but primary is delta. So current will not flow through the line connected to the delta winding. So current will not flow through line M. So here there should be a break, and current has to circulate here. So for current to circulate, this point has to be connected to the ground. This side has to be grounded. Otherwise current will not flow. There is a break here. Delta connected winding, current through the delta connected winding cannot flow through the line connected to it. So here we have to provide a break. So in order for current to circulate, we have to provide a path here. For that, we have to ground here. Okay, so this is the circuit. Now delta delta, the last configuration is delta delta. So we know there is path for current in both the windings, but current cannot flow through the line connected to it. So current cannot flow through line M as well as through line N. So break should be provided on both the sides, but current need to be circulated. So this side has to be grounded and also this side has to be grounded. So current can circulate through the winding like this, through this path. Okay. So these are the zero sequence networks corresponding to the various winding configurations. Now moving on to the sequence networks of loads. So for loads also, for loads can be either star or delta connected. Loads are generally motors, induction or synchronous motors. So motors means their winding can be either star or delta connected. For balanced star or delta connected loads, the positive, negative and zero sequence impedances are considered to be equal. So like transformers, for loads also, all the three sequence impedances are equal. Z1 equal to Z2 equal to Z0. And if the neutral point for a star connected load, if the neutral is grounded through Zn, then 3Zn will appear in the zero sequence network. As in the previous cases, for zero sequence networks, 3Zn will appear in the zero sequence network if neutral is grounded through Zn. 3Zn will appear in series with the zero sequence impedance per phase Z0G. Okay. Now the diagram, regarding the diagram, in the diagram, that is in the zeros in the network, the respective impedances are represented as shunt impedances. So for transmission lines and transformers, sequence impedances are represented as series impedances. But in case of loads, the respective sequence impedances are represented as shunt impedances in their sequence networks. So positive sequence network is represented like this. The positive sequence impedance Z1 is represented as a shunt parallel connected impedance. IA1 is the current flowing through it. VA1 is the voltage across it. Similarly, we can draw the negative sequence network also. So now moving on to the zero sequence network. Here also the zero sequence network depends on the winding configuration. The zero sequence network of loads also depends on the winding configuration, whether the load is star connected or delta connected, and if it is star connected, whether the star point is grounded or not. See, for an ungrounded star connection, zero sequence current will not have a path to flow. Zero sequence currents always need a ground path to continue. If neutral is grounded, zero sequence current can continue its path. But ungrounded star connection, there is no path for zero sequence current. So we have to represent a break here. Zero sequence current cannot flow through the zero sequence impedance. So there is a break here. Now the second connection, star point grounded. Star point is solidly grounded. Zn is not present here. Star point is solidly grounded. So current can flow. Zero sequence current can flow. So circuit can be shown as continuous. So next is star point grounded through an impedance Zn. So we know in this case we need to represent 3 Zn in series with Z0. Okay, so this will be the network. And for delta connected network, zero sequence current cannot flow through the line connected to the delta connected winding. So the current cannot flow through this line. So we have to show a break here. But current has to circulate through this winding. So this point has to be connected to the reference bus or to the ground. So current can circulate like this. So this is the network corresponding to delta connected network. So this delta connected load. So this is how we can draw the zero sequence networks of loads. And positive sequence and negative sequence networks are simply represented as shunt impedances. So one more point is there in case of transformers. If for star point grounded connection, there can be one more case. Star point grounded through Zn. So if star point is grounded through Zn, then 3 Zn will appear in series with Z0. For all the cases where star point is grounded through Zn, 3 Zn will appear in series with Z0. So consider that also.